So for this section, we're going to actually be still doing a little bit of what we talked about in section 5, because that whole section was about this fundamental theorem of algebra. But we're going to kind of also go the reverse direction. So instead of us just trying to find all the roots, there's going to be some where they actually just say, here's all the roots to a polynomial expression, and we want you to find the polynomial that they came from. So we did this with quadratics back in chapter 2. They would say, like, here's your roots, here's your two answers, figure out what quadratic equation they came from. And so we would write it out as like x minus, it was always x minus the roots. So x minus whatever those solutions are that they gave you. And then you guys had to multiply them. So when we were doing them with the quadratics, you only had two. So we always FOILed. We was at first, outside, inside, last, in order to multiply those. Now we're still going to do a little bit of that today with the FOILing method, but because we're going to have more than just two answers, like you might have 3 or 4 roots, you're going to have to write out however many that you need, and then when you multiply them, you might have to do FOILing like more than once. So you might have to kind of split it. Like I'm going to put these two together and put these two together, multiply them, and then you're going to have two new expressions you're going to have to multiply together as well. So we've done a little bit of like this multiplying polynomials. We did that at the start of the chapter. And so you're still going to be kind of bringing some of that back into what we're doing today. So let's go ahead and just look at this first example. We're going to kind of review what we did when it was the quadratic. So it's saying let x equals -2 and x equals 7 be the zeros. We're just trying to figure out what equation did these two come from. So we're going to start by writing in parentheses x minus, and you're going to put in the zeros that they give you. It's always x minus, okay? So the first one is going to be -2, and the second one is going to say x minus that +7 that they give you. For this first one, because you have a double negative here, because it was x minus that -2, I would change that to a plus sign. Think about your keep, change, change rule. Both of these are going to change to plus signs. So that's going to become x plus 2. And then x minus 7, like that. Okay, so now what we would do is FOIL these two things together in order for us to multiply. So as this were first, which would be the first two terms in your parentheses, which is the x and the x. So x times x is going to be x squared. Remember, outside would be the two terms that are farthest away from each other in the parentheses. So the first x and then that -7. So that gets you -7x or -7x. Inside are going to be the terms that are right next to each other here, where those parentheses kind of sit next to each other. So the 2 and the x. And then last would be the 7, or the -7 and the 2. So that's going to be -14. Last thing I can do is combine these middle two terms, because they both are just x's, so they're like each other. So I'm going to have x squared, and then -7x and 2x is going to be -5, so -5x, and then -14. Okay, so and if we kind of think about this, if I wanted to factor this problem, I would need two numbers that multiplied to a -14 and added to a -5. So if I was going backwards, those two numbers would be a -7 and a +2. So it'd be x minus 7, x plus 2. But when I set them equal to 0, that's when they switch signs. So that's how I got +7 and -2 for my solutions up there. So this is just a quadratic. Okay, now we're going to do the same thing moving forward with more than just two roots. So we're going to get into like cubic functions and quartic functions, like where you have x to the third, x to the fourth. So depending on the number of roots that they give you, that shows you like how, like what the highest degree should be. So if you have 3 roots, 3 real roots, you're going to have x to the third. If you have 4 real roots, you're going to have x to the fourth. You set them up the exact same way. So if you look at this next one, we have x equals -2, +2, +3. These would be all of the zeros. So we're going to start it out x minus all of them. And we're going to do this 3 times because there's 3 roots up here. we're going to do x minus -2, x minus +2, x minus +3. The only one that you could maybe change is the first, because it's got those double negatives again. So I'm going to do x plus 2 for that one. I'm going to leave the other ones alone. For this one, because you have more than just 2 roots, it doesn't work for us just to FOIL the whole thing. You're going to have to kind of split this apart into a couple steps. So I'm actually going to group these first 2 together. Okay, so the x plus 2 and the x minus 2. I'm going to FOIL these ones. So I'm just going to kind of leave that x minus 3 where it is for now. I'll come back to it, so don't forget that it's there, but we're not going to worry about it right now. I just want to FOIL this first set. Okay, so why don't you guys take a minute and actually FOIL that yourself. X plus 2, x minus 2. Okay, so when you FOIL this, your first term should be x times x, so x squared. Outside should be x times that -2, so minus 2x. Inside would be 2x, and last would be a -4. Because these are opposite signs, like you had one that was x plus 2 and the other one says x minus 2, those middle terms are always going to have opposite signs, so they're going to always cancel each other. So the -2x and the +2x just becomes a 0. And so I'm really left with just x squared minus 4. Okay, now I still need to bring down x minus 3. So I'm just going to drop that right next to x squared minus 4. And then your guys are going to FOIL again. Or you guys could use the box method. If you guys remember the box method from the first part of this chapter, you guys can use that. Even though this is easily able to be FOILed, you could still use the box method if you liked that method better. Okay, so go ahead and try to FOIL this one to get your final answer. So first should have been x squared times x, which is x to the third. Outside terms would be x squared and the -3, so that's -3 x squared. Inside would be -4 and x, so -4x or minus 4x, and then last would be -4, -3, which is +12. Now for this one, there are no like terms. Everything's different, so I can't actually combine, so this is my final answer right here. Okay, and again, if I really wanted to check this, I could go backwards now that I have my equation, and I could factor this and solve for my roots, and I should end up with -2, +2, and +3. So that would be something like on a test. If you had some time and you wanted to go back and check your work, you could always factor it and make sure that you got what they told you should have gotten. Now, before we go on to this next one, remember how up here when we had x plus 2, x minus 2. I said that they had opposite signs, so those middle terms were always going to cancel. This kind of leads us into the next thing that we're going to talk about, which is that word conjugates. And we've talked about these before when we were looking at square roots and like imaginary roots. We always talked about if you're given one imaginary root, there has to be another one out there somewhere, and that's the conjugate. So remember, in all of these examples that we've been doing so far throughout the second half of this chapter 3, we've been square rooting a lot of things, and I've always said put a plus minus sign in front of it because it's always positive and negative. So when I'm dealing with imaginary roots, like number 3 has an imaginary number I, that also means that because I have just regular I, there's also a negative I out there too. Because somehow to get an I, there had to be a square root of a negative somewhere in my problem. And if I'm square rooting something, there has to be a positive and a negative side to things. So when you guys see imaginary numbers, you have to make sure that you also add in the other root. So you also, I would just add on here at the end a negative I, because that's the conjugate of positive I. You just changed the sign of it. So if it was negative 2i, then the other root would be positive 2i. Now setting it up looks exactly like what we were just doing. So I'm going to do x minus 1. I'm going to go ahead and skip over here and do x minus 2. I'm going to keep kind of my real numbers together, and then I'm going to stick my imaginary numbers together. So it's going to be x minus I, and then x minus a negative I. Which again, because it's x minus a negative, I can change that to a plus sign. So if you guys want to go ahead and just change this up here right away, you can. So this is actually having 4 roots, which means that when I get my final answer, I should have an x to the 4th in the problem. That should be the biggest exponent that I see. And I'm going to do something similar to what we just did. I'm going to group these. Now, since there's 4 terms, I'm just going to kind of split it in half. I'm going to group the first 2 together, which is why I put the real ones together, because I'm going to try to make it a little bit easier on myself. And then I'm going to put those imaginary ones together too. Look at the imaginary ones though real quick. After I rewrote it, it now says x minus I, x plus I. It's the same situation as what we saw up above where it said x minus 2, x plus 2. Those middle terms are going to have opposite signs until they're going to cancel each other out. That's also why I'm putting them together, is so that I can get that to happen. So let's just work on the real numbers first. So x minus 1, x minus 2. Let's FOIL this one to get started. So first would be x times x, x squared. What would be my outside term? Or just the first set, what would be the outside term? Negative 2x. What would be your inside? Right, negative x. And then last is going to be negative 1 times negative 2, which is positive 2. So what's going to be negative 2x? Right here, negative 2x minus x. What's that going to become? Okay. All right, let's do the second set now. I'm going to FOIL this once more. This time I'm looking at just the imaginary parts. Okay, so the x minus I, the x plus I. First is still going to be an x squared. Outside is going to be x times your positive I. So that's just I, x. And then inside is going to be negative I times x. So again, notice how they have opposite signs. They're going to cancel, which is what I want to have happen. And then last is going to be a negative I times an I. So that's going to be negative I squared. All right, so my middle terms cancel. What can I replace an I squared with? Close. Negative 1. Remember, I squared represents negative 1 underneath the square root sign. Okay, so I can, anytime you guys see I squared, you can replace it with a negative 1. So let's talk about what we have left here. We have x squared, and then it's that minus I squared, which we said it's negative 1. So what would be minus negative 1? How would you rewrite that if it's minus negative 1? Plus 1. You got double negatives again. So it's going to be x squared plus 1. Okay, notice now I have no more imaginary numbers. You guys see how they're gone? There's no more i's. That should always happen here, okay? Because when you dealt with the conjugate, you got rid of the imaginary number. That's why we did that. So when you guys get to these problems, even though they throw imaginary roots at you, you should not have imaginary roots in the final answer for your polynomial. Because it was minus an I squared, and so this becomes minus a negative 1. And if I have double negatives, that becomes a plus sign. So that's where that came from. Okay, last thing then is to multiply these two things. And you guys can either distribute or you can use your box method, whichever you would rather do. Okay, so I'm going to go ahead, we're just going to refresh on that box method real quick because we've been doing some of this distributing already. So remember I would do like x squared minus 3x and a 2 that would kind of go across the top. And then x squared plus 1. And this isn't like a true box. It's not a square box anyway. It's more like a rectangle. But it's still going to work. So I'm going to do x squared times x squared, which would be x to the 4th. X squared times negative 3x would be negative 3x to the 3rd. And then I have a 2x squared. It's across the top. And then across the bottom here, I'm going to have x squared minus 3x plus 2. There's not a whole lot for like terms. X to the 4th is going to be all by itself. And I've got that minus 3x to the 3rd. Now, x squared and 2x squared, those are really like the only like terms that I can combine here. So that's going to give me 3x squared. And then I have minus 3x and plus 2. Okay, so to end up this section here, we've got a couple more examples. We're going to kind of go back to solving. Now that we've kind of seen how we can find some of these roots and factor a little bit, we can also just apply some of those same rules or same thought processes to these next couple of problems. So I would try to factor first if you can. If you can't factor, then you're going to want to resort to your P's and Q's method. But I would really look at the problem and see if you can factor it. If you start to see that it's just not going to work to be factored, then don't waste your effort on that. Go to the other method instead. For this one, I have x to the 4th minus 81. Now, before you just, okay, I'm going to add 81 and I'm going to find the 4th root. Remember, I got to find 4 answers to this problem. Okay, so if I do that, that's only going to give you 2 because you're going to have like the positive and the negative root of that. So there's still 2 out there that are missing. So we need to find them. I'm going to first think about how could I factor this? I've got x to the 4th, so I'm going to go ahead and split it. X squared, x squared. What 2 numbers would I multiply together to get a negative 81? It has to be the same number. 9. So one has to be positive, though. One has to be negative. So I'm going to do like x squared minus 9, x squared plus 9. This is really talking about like the difference of 2 squares. And we saw that back in chapter 2. The only thing is instead of squares, this is actually a 4th root. But I'm splitting it the same way that I would have split that. If it had said x squared minus 81, we would have x minus 9, x plus 9. This just has an x squared now. So I'm going to set these both equal to 0. So x squared minus 9 equals 0. We'll start here first. I'm going to go ahead and add 9. So I get x squared equals 9. I'm going to square root that. And I'm going to get plus or minus 3. Positive, negative 3. Now I'm going to do something similar with the second. So x squared plus 9, set that equal to 0. How would you solve this one? Subtract the 9. So now it's going to say x squared equals a negative 9. I'm still going to square root, but what is my answer going to look like this time? 3i. Why I? Because it's negative 9 underneath that square root sign. Okay, so because it's negative, I want to make sure that I pull out the I. So there's your 4 roots. Positive negative 3, positive negative 3i. All right, let's go on to the next one on the next page. So I would, like I said, try to factor this one. The only problem with this is there's 5 terms, and they don't have anything that I could take out of every single term. Like, I can't even take out an x, because the last one doesn't have an x. And I can't split this evenly if I want to try to factor by grouping, because I can't split 5 evenly. One would have to have 2 terms, one would have to have 3, but how do you know which one gets which? So what I'm going to do is try to do my P's and Q's method here. Which number is going to be your P for this problem? Okay, so the 8, don't worry about the negative sign in front of it, because all of our roots are going to be plus minus. What's your Q? 1. So factors of 8 are going to be 1, 2, 4, and 8. And factors of 1 are just going to be 1. So you're just putting all of those numbers over 1, which is not going to change them. It's just going to be 1, 2, 4, and 8. Positive, negative that we're testing. Okay, so let's go ahead and test. Let me see. I believe 2 is going to work for us. So I'm going to go ahead and have us test 2. Grabbing my coefficients from up above here. So 1, 4, negative 3, negative 14, and negative 8. Bring down the 1. And then go ahead and do your math here. Okay, so 2 is a root. If I rewrite this one, it's going to say x to the third plus 6x squared plus 9x plus 4 equals 0. Okay, now normally when we got to this point, we were able to either factor or use the quadratic formula, but that was normally because it said like x squared. This still says x to the third. So I'm going to do my PQ method one more time, this time with this new expression, this new polynomial. So I'm not going back to that original one. So for this one, your P is 4, your Q is 1. So factors of 4 would be 1, 2, and 4. Factors of 1 would just be 1. So you get 1, 2, and 4. Okay, I'm going to go ahead and have us do -1, because I know that one's going to work. Now I'm going to grab my coefficients from this polynomial here, the one that I'm circling. So 1, 6, 9, and a 4. And we're going to do that same thing again. Okay, so -1 is another 0. That works. So then I'm going to go ahead and write a new polynomial. So it's going to say x squared plus 5x plus 4. Now this one I should be able to factor. What are two numbers that I multiply to 4 and add to 5? 4 and 1. So we're going to do x plus 4, x plus 1. So if you guys set those both equal to 0, what do you get for your two roots? Good. Okay, so here's your zeros. Let's see, we had -4. That's the smallest. -1 actually shows up twice, because I got it down here when I factored, and I got it up there when I was testing it with that synthetic division. So -1 is going to have a multiplicity of 2. And then last is going to be 2.